application, and then we'll jump into the next slides and we'll jump into more in details about how to start working on HANA. And Arun, are you being given access to? Are you being given the connection details to log into HANA?
Not it.
Okay. I hope that you might. I hope you would get that soon. And what we'll do is today, after few slides, we'll straight away go into the HANA box and we'll start working on HANA. And once you know how to use it, hopefully they'll send you the links to the HANA box and you can go practice it yourself. All right. So HANA, let's go over the slides. Okay, so in the last class, we saw that HANA is a powerful machine which has a high memory and also a powerful process combined together, along with the software that's built specifically for computing, and that utilizes both the hardware and the software system in order to provide a faster data retrieval and storage mechanism, which is not possible in the traditional RDBMS systems. Some of the improvements were multi-core and also high parallel processing in the memory structures, and also the ability to store data both in the row-wise and also in the column-wise. So it doesn't fit just the traditional ER modeling and for the online transaction processing systems, but also it has the capability to store data in the column-wise trend, which will be very helpful in the analysis and analytical applications, which will also reduce the time drastically when we run reports against a huge amount of data set. Other possibilities include the partitioning as well as storing only the changed data set. That also reduces the load times. And HANA as such is an appliance, which means it's a combination of software and hardware. And the prescribed method is to use the hardware vendor in order to install the HANA software onto their own hardware systems, which are tuned in order to accompany HANA into the specific server environments. Main improvements in this particular RDBMS system or the appliance is that we have the ability to store the data faster and also retrieve the data in very short period of time because all the computations and the storage and the data that we need for analysis all reside in memory, and so there is no delay in the disk reads, which reduces the retrieval time in this particular appliance, and which is why many of the companies prefer using HANA for the real-time analysis or near real-time analysis, and also across a huge data set to create applications that are much flexible and which aren't being able in the other databases. There are different ways to load data into HANA. There are SLT landscape transformation mechanisms that we use as dedicated SAP server in order to configure the connection between the SAP ECC systems and HANA. We can also use an entire a third party, which is the SAP Business Objects Data Services, which can talk to HANA and retrieve data from multiple sources. One of the key advantages of using data services is that it can do multiple transformations when it retrieves data and before it stores data into HANA, which is not possible by the SLT replication mechanisms, where any kind of data manipulation will have to happen within HANA. There are also methods within the SLT replication that can retrieve data from SAP, which is by trigger mechanism, either by the log reads or trigger mechanisms, which will provide near real-time data into HANA, which is readily available for reporting purposes. So that way you can always have the very latest data. You don't have to wait for the batch processing that happens usually late at night to retrieve data of the previous day. The major contributors to the hardware are Dell, Cisco, IBM, Fujitsu. These are the preliminary uh, hardware vendors who helped SAP in order to shape their hardware architecture in order to fit HANA and best perform in their hardware systems. There are also additional hardware vendors recently, such as Toshiba, etc., which who also have hardware systems that can accompany the HANA software. And the key on this slide is that this SAP HANA Studio is the application that we use to interface the GUI that we use to interact with the HANA database system. The software is run on a OS, which is SUSE Linux, and that's the prescribed software prescribed operating system for HANA. We wouldn't much deal about it until we talk about backup and recovery, etc. But it's good to know that it's run on SUSE Linux. And also, on the same note, HANA is a enhanced software which is basically built upon DB2 or UDB, Universal Database, which is the proprietary database for IBM. So now let's look at the HANA architecture. On the right side, you'll see that there are the blue boxes along with the cylindrical data volumes and log volumes. So the large blue area here is the core of the HANA operating system or the HANA appliance. So let's first see how HANA works and what kind of processes run within HANA. HANA as such is it is based upon a traditional RDBMS system approach, but it's different in the way the software is designed and the other processes that are run that make it an in-memory computing system rather than a traditional RDBMS. As such, for any database, the final data will have to be stored into disk, because in HANA there is a large amount of memory that is utilized for all computing and retrieving purposes. But finally, after all the operations that are done in memory, during a commit, you will always have to go back into the disk and then store it before the system shuts down. So all the data finally gets stored into a disk storage, which is now classified into two areas within the disk. One is the data volume, which stores the actual data, which is the raw data that we use for the computation, and the log volumes, which always stores the different changes that are happening within the database system. So every time you make a change, this is similar to the concept of redo logs in the Oracle. If you're familiar with the architecture of Oracle, Arun, are you familiar with the internal architectures of any of the databases like SQL Server or Oracle?
No, but the the database is Oracle, right? So little bit of that web oriented in Oracle database.
Okay, are you familiar with these concepts of redo logs or undo database, undo table space, etc.?
No.
Okay. What happens is that every time you run a DML statement, either you update or you insert, that particular data always gets stored in the memory. And when you say commit in your statements, after you write a DML statement, that's when the database pushes that particular data set into the disk. Until then, the data completely resides only in the memory of the server. Okay, so for example, let's say you insert a record, you create a session in a database, let it be Oracle or SQL Server. In the SQL Server is a little different in that there is an auto commit in SQL Server, so that every time you write a DML statement, it automatically commits after each statement. Let's take, for example, Oracle. When you write an insert statement, you create a session in a SQL Server window. After you insert a particular statement without giving commit, if you do a select on the same table, you will be able to view the data that you inserted. But if your friend is also making a connection to the same database and he tries to select data, he will not be able to see the data that you inserted until you issue a commit. When you say commit, it goes and stores that particular data into the disk, and once you say commit, you both will be able to see the data. Until then, only your session will be able to view the data because it's in memory and you control that particular space. So these kind of logs are also stored by the database just in case if a database goes corrupt or if the system fails. So when you are in the process of inserting a huge amount of data set, database keeps recording all the changes until you issue a commit on a system. So in case if the database or the disk failure happens, these logs can be applied to the database when the system recovers so that all the missed data can be processed again and replaced in the disk of the database server. So these kind of the ongoing storage of all the changes happens in form of logs, and that's what gets stored into the log volumes. The actual data gets stored into the data volumes. Does that make any sense to you, or?
Yes, I got it.
Okay, good. Because it is very important when we talk in the backup and recovery, we need to know what is a log volume and what is the data volume. So that this concept is very important. So next comes the persistence layer. So the persistence layer is the layer where it's in between the memory and the disk storage. The persistence layer as such is a part of the memory structure and it is not a part of the disk. So whenever HANA as such can retrieve a huge amount of data, like we saw in the last class, like it can store up to 2 terabytes of data in its memory, right? But in case if you need some data which cannot be a part of the 2 terabyte. If you want some other data which is not processed in memory, then those kind of data will have to be requested in by the software into the hardware system, and the hardware then goes and fetches the data, searches for the data in the disk storage, and fetches that data, and then places it into a temporary staging area. Okay, and that particular swapping of memory is called page management. So whenever all the data cannot be processed in memory, your part of the memory is now swapped with the data that comes from the disk, and that kind of the transfer is called paging, and there is a particular specific process that is dedicated for processing these kind of paging mechanisms, and that is the page management which is happening in the memory. And the logger will also log any kind of changes that happens in the temporary staging area. So when you want to fetch a particular data, either to modify or to view, all that happens is that initially the data from the disk gets stored into the temporary memory space within the memory area. And in case if you also make any modifications such as update or change anything else using any of your ETL tools, all that gets stored into the memory structure, but like I said, without a commit. When you issue a commit, all the logs that are stored in memory then gets transferred to the disk storage, and also the background process will now go through each of those logs and then apply all the changes in the disk. Okay, so persistent staging area is persistence layer is the place where the required data from the disk gets stored into the temporary area within the memory. This happens very rarely though. All the data that you need when the HANA system is operational will already be in memory. Okay, this layer will be very useful only when the system has to be recovered from a failure. HANA as such, they spend millions of dollars in installation and setup for HANA. Usually in any company, if they had to use HANA, they will spend about $20 million to set up HANA. So in that case, what happens is that they will have all the backup and recovery mechanisms and backup disk as well as backup power, etc. in the data center. So the HANA system will be available 99.9999% of time. In case if something terribly goes wrong, or if there is a software corruption or anything else, that is the only time when the system has to go through the process of recovery mechanism from failure. Otherwise, this particular layer will be mostly used for backup and recovery, and also to store the logs or transfer the logs into a different system. Okay, until otherwise you wouldn't go through this particular process of recovery mechanism, which is very common in the regular database systems. Okay, the other layer, the other place where this particular memory structure is useful is that whenever there is a change in the ECC system, before that I need to explain the SLT mechanism. So system landscape transformation. What that system landscape transformation does is that it goes and looks for all the changes in the ECC system against the delta table. Okay, so when it goes and fetches that information either by trigger mechanism or by logs in the ECC system, it picks that data and then places into the temporary staging area in the persistent layer. Once the logs are placed in the temporary staging area, the data that is stored in the disk will then be processed in regular intervals determined by the software system. We can also tweak that, and also it can apply those logs into the disk area within the HANA system. So let's say if you have configured a trigger based replication for Mara table, so if there is a change to the Mara table, the trigger based mechanism will be based upon the base table, and it is purely driven by the RDBMS system. But if you go for the log based mechanism, then every time there is a change to the Mara table, then that change will then be transferred in form of a log into the HANA system, and HANA system will process that log in order to apply the changes to the Mara table instance within HANA system. So those kind of data will also be stored into the persistent layer. So there is another use for the persistent layer as well. All right. The page management, for example, in case if you are storing more data, if you are using data services is a third-party application. And what it does is that when it interfaces with HANA, it tries to process everything else within in-memory of the HANA server as well when there is an update or an insert done to the HANA database. But there is a limitation for processing done by database in regards to a third-party application. In that case, when you use data services, this is something that you will also see when we configure data services later. But now, you just need to know that there are two options available when you run your data services job. One is in memory and second is pageable. So when you are running a particular job in data services, when you select in memory, all the processing will utilize the memory of the target other source database or the source server. Source of the target server. When you select pageable cache, what it does is that it tries to do as much as processing possible using a limited amount of memory within the system, and whenever that particular processing is complete, let's say if you are processing 1 million records, it can split that 1 million records into 5 different processes of 200,000 records each. So whenever the first batch of 200,000 records are being processed, it will then transfer that particular change into the disk, while the other 200,000 records can still be processed in the memory without an impact to the memory in a large, in a large phase. So there won't be much of a footprint in the memory when you select pageable cache. If you select in memory for the entire process, all the 1 million record processing will have to happen in memory, which might have an impact on the server performance. So those kind of page management will also have to be handled by the persistent layer. So the next main region is the relational engine. Whatever data that we store in the disk will have to be will have to be displayed or interfaced to the end user in form of tables. So the method that we select during the storage selection will have to reflect how the end user sees the data within those tables. Those kind of transformation and the setup of the tables happen in the relational engine space, which also stores the metadata also in form of either the column or the row wise, depending upon the type of metadata stored within the database. So row and column store, as such, we know that we can store the data into either the row-wise or column-wise, and this is handled by the internal services that are running in HANA. The storage mechanism as such doesn't much matter in the disk area, but the segregation of how the data gets displayed or used is entirely dependent upon relational engine. Because when you store data into the disk, it is simply in binary. Whether to have a continuous stream of memory structures or memory addresses, or to have separate, segmented memory structures is entirely upon the software system. So that is handled by the relational engine, by by whatever methods that you selected during your table creation time. This particular area or the process will control how that how that table data should look like and how the table data should be perceived. So there is a dedicated service that is, that is going to handle either the row-wise or the column-wise storage of data, and that those kind of activities happen only in the relational engine. Until relational engine area, we wouldn't see any difference between how the data is stored, whether in column or row-wise. Once the data gets retrieved from the disk and then moves to the persistent layer and then jumps to the relational engine, that's when the classification of row-wise and the column-wise storage comes into picture. On top of that data, we have the request processing and execution control, which has the the decoding scripts for all the SQL parsing, etc. You can also interface with the MDX systems that can consume MDX queries. The other SQL-based parsing as well as the calculation engine, everything is handled within the request processing and execution control phase. So it's the more of the the program layer within HANA, and on top of it is the session management. So that controls the user authentication and also the amount of number of processes that can connect to HANA, and also it controls the data retrieval and retrieval and also the insertion processes for that can govern with each of the session. There is also a dedicated process for the authorization. When we set up the user roles and authentication mechanisms, then we'll talk more about the authorization manager process. So these are the main processes that are running within HANA. The important process that we will be dealing with mainly during a setup of HANA or during the administration mechanisms or the log volumes, data volumes, and the replication server process, which is another process which can be pushed down to HANA. Sometimes the replication server process can also be split into the read and write process, where the read process can be handled by the SAP ECC server, and the write process can then be in the HANA system. So there are multiple ways that we can split this replication server depending upon which server has the best performance. Other than that, the rest of the systems are all internal, and we wouldn't be much dealing with those because it's meant for the HANA to operate properly. Okay. On the left, we see the ERP system. ERP system has its own database and also the load controller. The replication agent and log mechanisms comes into picture when we install the SLT replication system on the ECC system itself. Sometimes the replication agent can also be set to a separate system as a separate SLT server. So in that case, all ERP system will have to do is simply log all the changes, and also there will be a additional read process installed on the ECC system. Once the read is done, it will then transfer that data into the SLT server, and finally that reaches the replication server area within the HANA server. Once it reaches the HANA server, it can then be placed into the queue for the logger mechanism and then will be applied to the disk as and when it gets processed. The other systems such as data services and also the BI systems either connect to the page management, or they can also connect to the MDX systems and the SQL script systems, depending upon what type of tool we use. So if you are using a tool that can both insert and also read, they will go directly into the persistence layer. But if you use a system such as reporting tool that simply reads data every time or simply issues a MDX query or a SQL query, then that goes through the request processing and execution control. And the system accesses the persistence layer only when you use ETL tools or some tool that actually interfaces with the database tables to make any change. But if you are using simply read-only tool such as a reporting tool in business objects, then it will go via the MDX system. On top of all this is a software that is created in order to interface with the database. Here the database is the in-memory computing engine, the larger blue box. The software that we will always use to interface with this will be the in-memory computing studio. In short form, it is called as HANA Studio. So we will be doing modeling and also administration. There are other tools or other UIs also available in the HANA Studio. We call it perspectives. So there are other perspectives such as development perspective and also a few other perspectives that you can customize also. So all that happens within the in-memory computing studio. In this diagram, Arun, do you have any questions on any of the parts within the within this diagram? We can talk about that in more detail if you have any questions on it.
Yes, Prakash. The BO enterprise. So you told like the data service or the BI directly for inserting the data and retrieving the data from presentation layer. If they want to use like the MDX or any of the controller, it will use for the reporting purpose. They can retrieve the data from the BI system, and then in HANA they will show up as the report by using this execution control without inserting the data into persistent layer.
That is correct. Yeah.
Oh, okay. That was so we can directly using the control for reporting purpose. We can directly fetch the data from BI content and then we can control.
For fetching data, you simply issue a SQL segment. For example, business objects, we have two ways to access data. One is by using analytical views that you create in HANA. Analytical views are similar to info cubes. So if you use BW, you will use BEX query. If you issue the BEX query, that will be converted to the MDX equivalent. It is simply an MDX query according to HANA. So whenever a BEX query is fired, it will go through the MDX query engine and it will get processed by HANA. If you use a simple BO report, such as a web intelligence report or any like crystal reports, that will be converted into the crystal reports is a little complex. It can either go through MDX or SQL script. But in case of say web intelligence report or the dashboards, it will go through the SQL parser, and the SQL parser will then convert those SQL scripts into the machine code. using all those engines within the SQL parser. So any reading, just read only systems will go through request processing. Any ETL tool, like you said, that inserts or makes modification to the underlying data or interfaces with the core database tables, that will go through the persistence layer, because persistence layer is a temporary staging area for HANA, right? So any change, because you cannot directly write into the disk using the tool. Using data services, you cannot directly write it into the disk. What you do is you will first place it into the persistent staging layer. You will not, but it will not be known to you. You will, when you import a table definition, you will import the table definition like any other table, like any other normal table, whatever name you give it to. Say you created a table called material master. So you will import the table material master, but when you try to insert data into material master, you will not directly write it into the disk. Whatever data that you write to the material master will get returned to the persistence layer. Okay, and after you are done with all your insert records, HANA will then schedule a job internally in order to apply all those changes in the memory into the disk whenever it finds an process and whenever it finds time. Because in case if the server goes down, unfortunately, what it has to do is it has to make sure that the server stores all the data as of the last commit. So it will have to always store the data and make sure that the disk, which is the final storage area, is up to date. But in order for you to retrieve data, whenever you write data, it has to be available for the reporting purposes too. Someone will have to immediately utilize it, or as long as there is space in memory that can accommodate that data, it will be in memory. Whenever there is a request for another type of data, let's say you stored only, you are utilizing about entire memory size for 2 terabytes, you are already utilizing 2 terabytes. Now there is a request by a business objects report which cannot be accustomed by the 2 terabyte memory space, and it has to come from disk into the memory, because this is a new data set which is not yet in memory. What it will do is it will see which is the least used memory within the memory space, because no one has used it for a long time. It will swap that particular memory space with the disk, and it picks up the data which is requested by the BI4 universe, and it places it into the least used part of the memory. That kind of swapping is called paging, and that is done by the page management with regards to retrieval of data. With regards to writing of data, whenever you write data, you always write it to the persistence layer only, and HANA will now schedule another process in order to apply the changes into the disk. And if you are writing a data which is there for a long time without any read request, then maybe after some time that particular data will be vanished from the persistent layer, and now that particular space or that is occupied in memory will be utilized by another read process.
Got it. Got it.
Okay.
One more question.
Yeah.
If the data is for from the persistent layer to the disk to write into this, by the time for the waiting persistent data, if by the time not failed, what will be the waiting data will be lost?
Yeah. Very good question. Yeah. This is a very valid question. What happens is that this is where the backup and the backup mechanism comes into picture. What HANA will do is HANA cannot immediately shut down. There are multiple layers of failures. So actually, remember we spoke about blades, multiple blades. So there is a mechanism called RAID 5. So RAID 5 is a harder architecture that will store data into multiple disks. And are you familiar with those architectures? RAID arrays. What happens is that whenever you store data, you will not store data in a single place. Okay. For example, let's say you have a table where in that table you have 10 records. For simplicity's sake, let's say that you have 10 records and you have RAID 5 installed, and RAID 5 or RAID 0, whichever way. The basic idea is that there are different RAID mechanisms that you can follow. Okay, the way that which is prescribed for HANA is that you store data in a way which can be easily recovered. So out of 10 records, and you have 5 blades, you store 2 records in each blade in subsequent order. So you will store the first 2 records in the first blade, third and fourth record in the second blade, and third and fourth in the second one, fifth and sixth in the third one, etc. At the same time, you will go and repeat the steps in the subsequent order. So now what you will do is, after you write the first 2 records in the first blade, now you will go and process the same set of data in order to write the second and third in a different memory space. Say third and fourth record in the first blade itself, but in a different memory space. Maybe I'm not. Let me write it down in the screen. Okay. So blade 1, blade 2, blade 3, blade 4, blade 5. Total number of records. 10. Okay. In the first round of storage, you will store 1 and 2 here. You will store 3 and 4 here. You will store 5 and 6 here. Okay. This is the way you will store data. Okay. On the second pass, what you will do is, in a different memory space, you will start storing 3 and 4 here. You will start storing 5 and 6 here, 7 and 8 here, in a different pass. So all this is happening within the disk. You will not write any program to store it this way. You will simply issue a command saying that, okay, in this, I also need to specify something here. So this is M1, memory space area M1. This is memory space area M2. Okay. Okay. So what happens is that, in case if one of your disk drives goes into failure, say blade 2 is now on failure, okay, what will you lose on blade 2? You will lose 3, 4 and 5, 6, isn't it? Arun?
Yes, Pravesh. Yes, Pravesh.
So if you look at the notepad, okay, out of 10 records, you have stored first 2 records on blade 2, third and fourth record on blade, first and second record on blade 1, third and fourth on blade 2, and fifth and sixth on blade 3 in the first phase. Next, on the second pass, it will store 3 and 4, 5 and 6, and 7 and 8. Although you are issuing a command to store only 10 records, it will be replicated multiple times. Say if you have 5 blades, it will be 50. It will be modified to 50 records. It will store it 5 times in different blades. Okay. In case if there is a, like you said, there is a sudden disk failure. Okay, the normal processing is going on, but something happened and there is an immediate disk failure. So this particular blade, the highlighted blade, will go offline, isn't it? This is failed, so this is not available for use. It is not online, it goes offline mode. But whatever data which is stored in 3 and 4 is now available in blade 3 and 4, blade 1 itself, 3 and 4. The 5 and 6 is not available in blade 1, but it is available in blade 3. So if this particular disk fails, the system will know where to go and fetch the 5 and 6 and 7 and 8. So in case of disk failure, the system will handle it internally in a way that in any point in time, if one particular disk fails, it has another place where it can go and fetch the same data. That is the concept of RAID. Okay?
Yeah, okay, Baba.
So if a disk failure occurs, it will store the data this way, and then it has a place where it can go and recover the missing data. In case of power failure, for example, if your HANA system loses power all of a sudden, the HANA system internally has a battery built in, like a UPS. Okay, the timing of the UPS is set in is up to a particular standard, which will allow the main processes of the HANA that is currently occurring to commit before it shuts down. Because there will be a we will talk about that in the the logging mechanism, because there will be a log ID. Every time there is a change applied to the disk, there will be a log ID issued by the HANA system. Let's say if your current log ID is 51, and between 51 and the next log ID 52, the system loses its power, the main power. The HANA server internally contains a small amount of battery that will allow the log ID from 51 to 52 to complete successfully in such a way that log ID 52 is completed, and after 52 the HANA server will go down. Okay, the user connections will be cut immediately when the power goes off. The top layer in this, you see the session management. The session management will be lost as soon as the main power is gone. After the session management, so which means that all the user processes will lose their connection to the HANA database. The internal battery built within the HANA server will make sure that the current log ID is committed before the server goes down. Okay? If it doesn't have the, if the HANA, it will compute internally to see if it has sufficient time to commit all the data. If it thinks that, if it can, whatever calculation it does, if it thinks that, oh, I don't have sufficient time to commit all the data, it will simply store the log into the log volume, hoping that when the server gets rebooted, it will first apply all the logs in the log volume into the data volume part of the disk before it brings up the entire database. So it will replicate the system just like the way it was when it got shut down. So the server is designed in a way to either commit all the changes before it goes down completely, or at least it can go and store all the log into the log volumes, and then when the server reboots, it will apply all the log volumes into the data volume in order to make it very in a consistent stage. Okay, and then it will bring up the server and it will enable the session management so that users can connect to it.
Yeah, got you, Paresh.
Okay. Okay. Yeah, because this was the basic question that came up with everyone when the HANA database was first put in market. So they initially they did not think about the internal battery system because they thought that in such a expensive system they should have power backups. But what happened is that an earthquake happened 2-3 years ago, and in the earthquake all the power backup systems in the data centers also went down, so there was no power. Then they introduced this concept in order to handle such situation.
Oh.
Okay, now from current slide. Okay, so this is a high level design slide, design architecture to show what lies where within the HANA landscape. The HANA appliance consists of database, which is the core of the HANA appliance. HANA client is simply an interface or a thin client which will connect any external system or any application that is running on top of the HANA appliance to the HANA database. So it is, just imagine the HANA client to be a ODBC driver. Okay. For now, just imagine it to be ODBC driver, but it is more than ODBC driver because it contains all the connection mechanisms and also the performance and enhancing drivers also within the HANA client. For example, if you are using data services to load data into HANA, you will have to make sure that you have installed the HANA client on your data services system. Only then can you connect to HANA. But now there are other options such as ODBC drivers which can also be used to connect to HANA systems. But client will always help you, HANA client will always help you to use a proprietary HANA connection mechanisms to HANA database systems. HANA Studio is the front-end GUI which we'll use to do modeling as well as administration, etc. on HANA. HANA load controller is more of what this is helpful when you configure the SLT mechanism, because the load controller will have to be residing in HANA server. And host agent is another service, backend service that will be running in the backend that can connect to the external systems such as the SLT systems, which is an ongoing process. I mean, it's always a running process in the HANA server. As soon as you enable the SLT replication mechanism, it has to always keep up and then pinging to the other systems such as ERP or SLT system, etc. Sybase replication server is an internal server which is borrowed from Sybase. It is also another way of replicating the system's data from the external systems. So Sybase replication server is also a separate system that can be installed, which can connect to external third-party systems as well as any system, virtually any system. But it seems to be a very complex process than the SLT mechanism. At the same time, it also needs to have a separate licensing. So when you use SLT replication, you don't have to purchase a separate license. But in case of Sybase replication server, along with HANA and the SLT, this is additional licensing that one has to pay. So most of the companies, they won't go for Sybase application server. Maybe if in future SAP decides not to charge for the Sybase application server, then people might start using that also extensively. for now there are only very few companies that will go for site-based application server. Only if they have previously used site-based application server. Otherwise, everyone will start either using data services or SLT. The other systems that are interfacing to SAP HANA are shown around the SAP HANA box. LT system. LT system is similar to any other installation in SAP. Just like BW system, you can install LT system, which can be a standalone system to the ECC, or you can also configure LT systems, some of the processes that are running on LT systems to be a part of ECC system, as LT then behaves as a bridging server between the ECC system and HANA appliance. If you are concerned about the performance impact of the logging mechanisms and the additional process that the ECC system has to do, then all that can be pushed down to LT system. And LT system can track and then read, process, and also transfer data into the HANA logging mechanism, which is a separate standalone system. Other ERP systems then talk to LT system. There is an interface that is available between the ERP systems and HANA in case if you use a trigger-based mechanism. The trigger-based mechanism is an RDBMS-driven mechanism. So in that case, you don't need an LT system dedicated for having a trigger mechanism. Rather, you can simply interface all the ERP systems to the HANA database, and the logs that are getting shipped will then be processed by the RDBMS services that can apply those changes into the respective tables. Data services again can connect to the HANA database either by means of ODBC, or it can also connect to the HANA systems using HANA client. There are basic systems that the HANA client is the basic application that will have to be installed in order to browse data and also view the metadata in HANA. Then once the metadata is imported, then you can either connect to a JDBC or ODBC driver in order to write data into HANA. The other systems such as the BOE, etc., which will use HANA clients, or there is a huge change in trend between the time the client systems were put in place to the recent JDBC and ODBC drivers. So earlier HANA client was the only way that we could connect, but nowadays the most prescribed methods are either JDBC or ODBC drivers. Now we have specific drivers that are available which can be downloaded from SAP website, and you can install it into the BOE server. And once you install it, then it is simply another driver just like Oracle or SQL Server. Now you can connect to the HANA database and you can start accessing the data within the HANA database. So this diagram simply shows that how and what are the different systems that can interface with the HANA appliance. And SLES stands for SUSE Linux Enterprise Server. So this was Service Pack 1, which was way back. This slide is a little old. That's why you don't see that ODBC or JDBC are part of this HANA, the central pink box. Now they have come up with the JDBC and ODBC drivers. Earlier, SAP HANA client was the only way that we could interface with HANA. Okay. Okay. Before we move to the next one, do you have any questions on this, Arun?
No, brother.
Okay. Now let's move on to the next one. This is the internal working architecture of how the HANA can be used either by. This is more of a concept for the admins where you can scale the HANA architecture, but this is done mainly by the hardware vendors. We cannot simply do these activities. That is, I need to say that first. As an administrator, we wouldn't be able to scale the HANA configuration. All we can do is we can administer the configuration that was set up and recommended by the hardware vendors. Okay, but it is good to know what are the services which are running inside the hardware system, so that in case if something happens or some kind of alert is being sent, the administrator can coordinate or contact the appropriate teams and not just run around. So the name server, as the name suggests, it's a particular service that is running inside the HANA appliance in order to specify what host it is, resolve the IP addresses to the host names, etc. And also it uses specific process for the servers to communicate with multiple systems. Index server is the server which will go and keep a regular track of indexing of all the data within the HANA database, because we will end up storing a huge amount of data, and like any database, this HANA database will also have to be indexed in order to retrieve data in a faster way. You're familiar with the index concept, right, Arun?
Oh yes, brother.
Yeah. I'll simply say what is the difference, so you will know other things better. So let's say if we have a table with a primary key, and that particular table may have 20 columns. Instead of going and passing through or scanning through all the 20 data columns, each of the data type might be varchar 30, 100, etc. So you have to scan, varchar 30 and then varchar 100, and you have to do it for every record in order to find a particular value within the table and the column. In index server, if you index it, it will be an integer, and it will be stored into a separate memory location within the database, and whatever the value that you are looking for, it will be against a particular value of an integer in the index server, which has an address to the actual data located in the table. So the faster retrieval happens because it has to scan only through an integer and also a value that you have specified for the actual names. So the scanning and retrieval process is much quicker, and this has to be done for faster retrieval process. And since we claim that the HANA is the most efficient server for retrieval purposes, all the data will have to be indexed in regular periods of time, and index server simply does that. Statistics server will calculate the statistics of a particular object within the HANA database, so that it gives you the current state of any object. For example, statistics include how many number of records does a table have, what are the indexes that can be used within a table. If there is an index that needs to be processed, then it will then communicate it to the index server to reprocess the index, and it has the basic statistics of any object within a database. Okay, preprocessor is the parsing mechanism, is an interface between the machine code and also the human readable programs. So whenever we issue a command, that gets converted to the machine code, and then that processes those commands into the language that the HANA machine will understand. So that's to do with the preprocessor. The other applications such as HANA Studio Repository, Host Agent, and Update Manager, these are the services that are running in the backend, because you can create multiple repositories, just like a general concept for the storage of data and metadata. We can also store each of our code into a specific repository. We can create multiple repositories within the same HANA database. You can, let's say, if you start making objects, creating objects such as tables, or also if you want to create a content such as um, you know, a view, an attribute view or analytical view, or you want to create a analytical view similar to the info cube. So if you want to create all those within your own space of a within your own development space, then you can create a repository for your team, and then you can all start storing all the programs and also data into that particular repository. So HANA Studio repository will be useful in order to do all those tasks. Host agent, again, it is simply a service that runs in the backend in order to in order to identify itself within the network. If you have a cluster, which is shown on the right side, so if you have a cluster configuration, which is a multiple host configuration, you will then have each host agent running specific for each of those physical server definition. So host agent is simply a background process which will help in order to identify within the network of which particular part of HANA database it belongs to. So software update manager is more of automatic updates that can be triggered by using solution manager. So software update manager can be interfaced with a solution manager in SAP, and it can then automatically go fetch all the updates because SAP HANA has been going through lots of changes and improvements, and every time there is a new update available, software update manager can automatically go and fetch all those updates, and it can be configured either to update automatically, or it can be queued up, and then an administrator can go and decide when those updates should be applied to the server. So this whole structure of the process are being stored into some kind of a recovery mechanism, or the failover mechanism, which is nothing but the RAID mechanism that we saw earlier. So all these processes will have to be controlled by either the default RAID mechanisms, or we can also have other third-party recovery mechanisms like Tivoli, etc., which can also be placed on top of the existing HANA server. But all these are not controlled just by the admin within the project. This has to be discussed very well with the hardware vendors, and hardware vendors will then recommend some kind of system that each of those hardware vendors use. For example, in case of IBM, if you go to IBM hardware vendor, they will automatically recommend Tivoli. If you go to HP or some other vendor, then they will try to use their own backup and recovery mechanisms. So it depends upon the vendor that we use within the client environment. This diagram is to show what are the different components. This is same as this diagram. It is just a different way of showing how the HANA packaging happens, which means what kind of components fall within a particular system. For example, within HANA system, you have the first box, which is the HANA database, client studio, everything else, and installed on a separate server, which means the data services and the SLT, like we know, which are external systems to the HANA, actual HANA database, because data services will have to be installed on a separate server, which will be the database data services management server, and you have all the job server, etc., configured for data services in a separate server. Similarly, for SAP SLT mechanism, you'll have to have another SAP instance which is installed for replication. ASC is nothing but the Sybase replication server, which is also a separate installation that can interface with the HANA to the external systems. The last one is the reporting tools. All the reporting tools now communicate with HANA either by using HANA client, or they can also communicate using ODBC and JDBC these days. So this is simply to show now what are the boundaries of each of the systems. So the HANA boundary ends here, and the next boundary for the external interfacing for ETL systems, then they come into picture here. Then the third one is the Sybase replication server, which is a separate installation. They would like to emphasize this part because they want to charge a separate licensing for replication server. In terms of data services and SLT is nowadays it's free. Data services, they do a subsidized licensing for data services if you purchase HANA. So data services and SLT is most prescribed and most recommended in most of the projects. ASC is something that can be looked into if the particular client is already familiar with the Sybase replication server, because otherwise they'll have to pay extra for just the replication server, which can also be done by using data services or SLT. So there is no special need to have a Sybase replication server. Okay, this is to show that in traditional databases there are two layers in the databases. One is the data layer where the actual data gets stored, and application layer is where all the all the transformations or all the read happens, and that is always a back and forth approach between the disk and the memory, and because of the application layer and database layer, it have to be as two separate layers. And now the HANA approach is that all the application layer functionalities such as say summarization or say for example if you are storing data in 20 characters length and you want to do a substring of first to 10 characters, so that you want to pick up only the first 10 characters of the 20 character length data. Earlier that particular command will come from application layer, and database layer will fetch all the 20 characters, and application layer will truncate the first truncate the last 10 characters and display only the first 10 characters. In HANA approach, whatever transformation that you would like to do on the data for viewing, everything can now appear on the database layer itself, because database layer, which is the in-memory layer, has also the capacity of hosting the application programs, and all the changes that you like to do in a traditional application layer will now be performed in the memory itself, which is much faster. So they don't have to go back and forth between the disk in order to fetch a huge amount of data. So earlier when you have written a select statement that runs in a say for 10 seconds, now it should run in 1 second or less than 1 second when you use HANA. Since all the data are already available in memory, all it has to do is to just apply all the changes in the from the command and then simply display the data without any delay. And this is again to show how the traditional database and what's the in-memory computing. They will keep talking about in-memory very often, just to emphasize the fact that all the data, whenever you access it, is present in memory, and you don't have to go back to the disk and then fetch that data every time you need it. Okay, so this is a different type of representation of the same thing that we discussed in the last slide. So all the application logic, aggregation, conversion, or any changes to the existing data can be done on the database layer itself. You don't need to create another additional interface between the database layer and the application layer, because application layer earlier used to access data based upon on-demand basis, and on-demand basis then it has to go and fetch data from the disk into the memory as and when required. But now, since all the data already exists in memory, they don't have to do that type of process. Rather, they can simply apply whatever the application code wants to do simply in the memory. So it's already pre-existing. All it has to do is to simply process the application commands in the memory and display it to the user. Right. Um, so the HANA component architectures are two-phase architecture. So you have the um, two-phase approach for the hardware and software components. The hardware components are mostly to do with the underlying database layer. So the core database is considered to be the most of the hardware architecture, and the software architecture is to do with the client studio, HANA Studio, and also the client that gets installed on top of the HANA database. So you always have this concept of the external interfaces or the UI that control the backend database. So backend database plays a major role with the hardware, and the hardware is a part of the underlying core database. Whereas whenever we talk about software, then we're talking about the HANA Studio or the HANA client, and the updates to the HANA database is a hardware-based approach, whereas the updates to the UI are software-based approach. All right. This is to show what's the difference between the row-wise and the column-wise approach for storage. I think we discussed this in the last class, but Arun, do you want us to go over this? What is the difference between the row-wise storage and column-wise storage?
No, Prakash, you can continue that. I know row and column is how it is.
All right. So now this is, before we go here, we need to, they actually have achieved all these stages. So they have achieved, when HANA first came into picture, they had only the interfacing mechanism using the client software, HANA client software, and they had some limitations on what kind of real-time operations that they can do, and also how much they can interface with BW and other ECC systems, because initially when they came up, they did not have the facility to host the ECC system on top of HANA. So this is to show how they plan to focus on the future, and now they have done everything else. So now you can host HANA, host ECC on top of HANA. You can also host BW on top of HANA. You can use HANA as a standalone application for the analytical processing. So they have achieved all the three phases for for storage, and also to run both OLTP as well as OLAP systems. Now, I think this is enough for now for the on the architectural side. It would be better if we straight away go to the HANA system and show you what the HANA system looks like. Before we do that, do you have any questions, or are you fine with us going to the HANA system and show you how the HANA system works and what is it, how you usually interface with the HANA?
Yeah, you can go ahead and show up the.
Okay, so this is a system that's been given to me. You should also get the system details and also the username password to log on to the system. I'll close this for now, and then I'll show you how to access HANA database. Okay. Okay, before we proceed, let me also show you the tip. Um, so now on Windows we have the users directory, right? And then we also have the my user ID that I am using to log on to the service HANA user 1. Okay. They may give you the same user ID or they may give you a different user ID. Whenever you open up HANA Studio, right, it creates this folder called .eclipse because HANA Studio is built on top of Eclipse architecture. Eclipse is the Java development environment, and what this particular folder will be useful in case if you have any issues when you are working with the HANA Studio. Let's say if you have any issues with logging into the repository or accessing objects, the easiest way to fix it is by going and replacing this Eclipse folder, .eclipse folder, into old .eclipse folder like I did here. So what it happens is that it tries to create a new .eclipse folder which will overwrite all the config settings, which will then eradicate all the issues that you had with the previous run of that instance. Okay. It seems that the user who was using this system earlier, they made some changes to the security, to this tool. So they went and I think they issued a super user password, okay, a common password for this system. But they forgot to register that user password into the documentation. So we had no way of knowing what that password is, master password. So the only way to reprogram the master password is to eradicate the existing configuration. So what I did was to go and rename this .eclipse folder to old .eclipse. So you can just remove that folder as well. It doesn't matter. I'm just preserving it just in case if someone wants to reuse it. Okay. So once we do that, it will. When I'll show you something here. Let's say if I say F2 and then say new .eclipse. Okay, this is being used because HANA system is open now. I want to show you this because in case if you log in using the same user ID and if I have had my own credentials, then you may have to do this. Okay, so you see that now .eclipse is gone, right? Arun?
Yes, Prakash. Yes.
So now you see that the first folder is .sdv,
Yes.
right?
Yes. Yeah.
Now I'm going to simply open HANA Studio. HANA Studio is on the bottom left corner. Are you able to see that icon?
Oh, yes, Prakash.
Actually, you go to start. Okay, the right path is go to start. You go to all programs. You go to SAP HANA, and then within that you will have SAP HANA Studio. Okay.
Yeah. Okay.
So when I click that, you see there is a .eclipse creator now. 731.
Yes.
So this is the easiest way to fix any kind of security issue with HANA Studio. So if someone else, so nothing gets modified. When you access HANA Studio, it is simply an interface. That's it. Whatever you do in HANA Studio gets stored into HANA database. But in case if you have any kind of issues with the security or any corruption with the current login, then the easiest way is to just come here and then change this folder, and it will start creating everything else. See, now it says a new master password has been created. Would you like to do so? I don't wish to, because it will ask you for a couple of questions that you need to answer. If you don't want to do that, you simply say no. Okay. All right. So this is the HANA Studio to start with. In HANA Studio, you go to Window. These are different perspectives. Perspectives are nothing but different UI interfaces within the HANA Studio. So you use HANA Modeler when you want to do modeling, which is what we are currently having. So on the top right corner, you will see that HANA Modeler is kind of highlighted here. When I switch to Administration Console, it will give me the menu that are specific to the Administration Console. So here I can go to repositories. I can go to the navigation attributes, navigation folders. So these are the ones that I can use to switch from one type of an interface to a different interface. When I'm working, when you're working as a, say, a developer or a HANA analyst, most of the work will be done using HANA Modeler. When you are an admin, then you'll start using Admin Console. Okay. There are other perspectives also. So, for example, if you want to do HTML5 coding, or if you want to create your C++ programs, all those can be done using HANA development. Okay, so the lifecycle management is more like the CTS in SAP. You can transform. You can have multiple instances of HANA just like any other database. You can have dev, test, and dev, QA, and prod, and each of these the HANA views that you create can be transported from dev to QA, etc. using lifecycle management. The rest of the things are all more towards the Java programming. So if you know Java and you want to create your own application or JSP scripts, etc. with regards to HANA, then you can do that using all those different perspectives. What each perspective will do is it will enable a specific tool to do tasks for that particular area. So in case of Administration Console, I can go and do system monitoring. So if I select system monitor, it will tell me what the system is currently doing. So all the services are started, etc. So which means that the system is up and running. So, but when I switch to HANA Modeler, Modeler is more to do with this is not customized, this particular, but we can also customize the perspectives. I got access only today, so I did not customize it very much. In Modeler, you can also create packages, views. We'll see what these views are. These are the main things that we need to know in the HANA database. So when you connect to a system, let's say once you log on, the first thing you need to do is you need to set up the perspective. So whatever you're trying to do, either you're trying to administer the HANA database, or if you want to do modeling on HANA database, you select the appropriate perspective first. Okay, and once you come here to the appropriate perspective, you then have to first register the system. So you add a system. So you will be given the host name, instance number, etc., which is just like any other system that you connect. Then you click next, next, next. But in our case, we already did that, and we have the system here. The password for this is 1234. Okay, once I log in, you will see that now I have different folders: catalog, content, provisioning, security, etc. Are you able to see those in the screen?
Yes.
Okay.
Yes, Pravesh.
So Now, once I log in into the system, now it will show me what is present within the system. So catalog, the two major folders that you will be dealing with is catalog and content. Catalog is nothing but it is the database object representation. Okay. By that, what we mean is that you can create multiple schemas. So the sysbig and sysbi, all these different names that you have, these are different schemas within the HANA database. The name of the HANA database is HDB. Okay. This is the HDB is the name of the database. These are different schemas within the database. And when I expand the schema, I will see different database objects within the schema. I will have tables, synonyms, sequences, procedures, indexes corresponding to the tables, column views, regular views. Okay. So these are different types of objects, database objects within the schema, which is all grouped into the catalog. So whenever, let's say, you want to retrieve data from a third-party system or ECC system, you will first have to create a schema, and then you will start creating tables within the schema. Someone has already done the ECC data schema creation, and this particular schema contains tables that have been retrieved from ECC system. So you see all these tables here. So these are the tables that have been retrieved from the ECC system. For example, KNA1, if I right click and then do view data, I will be able to see all the data that is stored within KNA1. On top of just view data, you also have other facilities such as distinct value selection for each of the objects that you can select. For example, if I want to know what are the distinct objects within KUNR, if I select, then it's going to tell me what are the distinct values and its distribution, etc. It can also give me the graphical representation of the distribution. So this itself will show you a simple, a report type of analysis. So if you know what kind of data that you are dealing with, so for example, if you have and then so I have this KUNNR count per region wise distribution. So you see that the same data that we had just in the table can easily be analyzed just by using the view data facility within HANA. Okay. This is not actual reporting though. This is simply to see how the data, what type of data resides within your table. That's it. All the reporting, everything will be done using the views. So attribute view, or are you familiar with the database terms like attributes, facts, master table, star schema? Are you familiar with those terms? Okay. So in a data warehouse, there is a concept called star schema. What star schema means, the data that you store in data warehouse is classified into master data and transactional data. The master data is called as dimension and the transactional data is called as fact table. It is just a different name, but the purpose is all the same. Okay, I'm trying to use the terms master data and transactional so that it is easy to understand using the SAP reference. Okay, so all the master data is called the dimension, and the dimensions are supposed to contain only the attributes of a particular object. Okay, let me draw a diagram.
Prakash, can we wrap up today or?
Oh yeah, that's fine, yeah. What we can do is we can stop here, okay?
Yeah, sure.
Right now, all you know is how to log on to HANA database, how to set the perspective, and once you set the perspective, how to log on to the system, okay?
Yeah, sure.
And once you log on to the system, you know what is catalog. You don't know what is, um, you don't know what is content provisioning and security. We'll deal all those in the next class. Catalog, in case if you are given the access to the system, you can go and you can see what the catalog is, and you can also try out, the open view data, the other options here, except, some of the critical things like do not do delete or generate, etc. No import export now. But load into memory, you know what that means, which means that you're loading it into SAP HANA's memory. Okay. So those are some critical things, but you can at least open data preview. You can get used to this environment. Okay. And in next class we will see more in detail about what are the different other folders, what are the views, and how to create a view, etc., and how to access a view from the reporting tools, etc. Okay. Okay. And we can do all that in the next class, not a problem. Okay. All right.
Yeah, sure.
Yeah. Good night.
Okay. Okay.